Want to build your own AI agent without any coding experience? We've made it simple by breaking it down into easy-to-follow steps. Having your own customizable AI agent can save you hours on tedious and repetitive activities like job hunting or being updated on the latest news relevant to you. In this tutorial, you'll learn how to set up a job finder by copying a script from GitHub, setting up your environment with VS Code, and connecting everything to OpenAI, Langchain, and Google search data. If you want us to create content like this and want us to keep on developing easy-to-use AI agents, like and subscribe to get more. If you're new to coding, don't worry. You only need to tweak a few things to get this running. I will be there to guide you every step of the way in this tutorial. First, create API keys. Second, add API keys to a .env file. Third, update the job role. As a quick demo, let's say we're on the hunt for a senior software engineer job. We simply add the job title into our function and prompt template. This function leverages a pre-built reasoning template that uses the chain of thought framework to simulate a human-like decision-making process. This approach allows the AI to think through the job search criteria step by step, making decisions just like a human recruiter would. With just a click of the Run button, our AI job agent processes everything and within moments. You'll see an organized table of results, job titles, locations, whether they are remote or not, salaries, and more. What normally takes hours of manual job searching is now condensed into just a few minutes and clicks. When you click one of the links, you will see that the job is indeed remote. Before we dive into the details, let me give you a quick overview of what we'll be covering in this tutorial. First, install essential tools. We'll start by setting up VS Code, Git, and Python, which are crucial for our project. Next, we'll clone the GitHub repository to get the project code into our local machine. Third, we'll create and activate a Python virtual environment to manage our dependencies. Fourth, we'll install all the necessary libraries and packages required for the project. Fifth, we'll configure the API key to enable our tool to fetch job listings. Then, we'll run the script and see our AI job finder agent processes job searches and returns results. As a bonus, watch till the end as we customize this AI agent for another purpose. Let's get started. First, let's download Visual Studio Code. The download link is in the description below. Choose the version that matches your operating system, Windows, macOS, or Linux, and follow the installation instructions. Once installed, open the VS Code app. On the left side, you'll see the version control button. Clicking this will redirect you to the Git website. I choose bit64 version for this project and leave everything at the default settings. Complete the Git installation by following the prompts. Next, let's install Python. I'm using Python 3.12, which you can download from the Python website. Make sure to check the box that says Add Python to Path during the installation process. This step ensures that Python is properly set up on your system. Now that we've set up our tools, let's clone the project repository. First, go to the Terminal tab in VS Code and click on New Terminal. This will open a terminal at the bottom of the screen. Next, navigate to the location where you want to save the cloned repository. For example, I'll navigate to my desktop by typing cd desktop. Now, head over to the Git repository of Aklat Cyber. The link is in the description below. Go to the repository tab and click the Job Hunting AI agent. As you notice, there are many branches in the Job Hunting AI, but we're gonna focus on staging branch. The other branches are all about the pagination for the SerpAPI, and the other branch is for adding an example format that will be included in the prompt template. Once you're on the staging branch, click the green code button. Make sure you're on the HTTPS tab and then copy the URL provided. Now, return to your terminal in VS Code and type the following command to clone the staging branch. By the way, I will add the script for cloning in the description as well. Once the cloning process is complete, you'll have the entire code in the staging branch saved on your local repository. In VS Code, go to the File menu and select Open Folder. Navigate to where you saved the clone repository on your desktop, then open the Job Hunting AI agent folder. You might see a security message asking if you trust the authors of the files in this folder. Go ahead and click Yes, I trust the authors. Now, you'll see all the files and code that we've just cloned. If you take a look at the Python scripts, you might notice yellow underlines on some of the import statements. This indicates that our Python environment and project dependencies aren't set up yet. To fix this, we need to install pipenv. Pipenv is a powerful tool for managing your Python environment and keeping track of the specific versions of packages your project depends on. This is all managed within two key files, pipfile and pipfile.log. We'll dive into these files a bit later. Once pipenv is installed, you can create a new virtual environment by running pipenv shell. This command creates a virtual environment specifically for our project, isolating it from other Python projects on your system. To make sure VS Code is using the correct Python interpreter, go to the lower right corner of the VS Code window where you see the Python version displayed. Click on it, and the list of interpreter options will appear. Select the virtual environment that you just created with pipenv. Next, we need to install all the project dependencies by running pipenv install. This will install all the libraries and packages listed in the pip file. As the installation progresses, you'll notice that the yellow underlines on the import statement start to disappear. That's a good sign. It means that the modules and dependencies are being successfully installed. With that done, we've set up our Python environment and installed all the necessary dependencies. Next, let's dive into creating environment variables to securely store your API keys. Within the Job Hunting AI agent directory, create your new file named .env. This will hold three critical API keys: the SerpAPI, the OpenAI, and Langchain. For the setting up your SerpAPI key, head over the SerpAPI site. Link is in the description. You'll need to create an account which requires email and phone number verification. Once verified, you can find your API key under your account tab. Copy it. SerpAPI offers 100 free search requests per month. And if you need more, you can switch to paid plan. They also provide the APIs for searching specific Google data like maps, products, trends, and more. For now, we'll focus on Google Jobs, but we'll discuss the API parameters in detail later. After you set up your SerpAPI key, let's now go to OpenAI. Get your OpenAI key by following the link in the description. Create an account and verify it with your phone number and email. Once your account is verified, you'll be given a free $5 credit, which you can use immediately. However, if you need more, you can always add credits later. Copy your API key and paste it in your .env file. Finally, you'll need to get an API key for Langchain. To get started, visit docs.langsmith.com. The link is in the description. Create an account. Signing in with Gmail is an easy option. Once you're logged in, go to the Settings tab and generate your Langsmith API key. This key will empower your AI job finder to perform more complex tasks by leveraging Langchain's capabilities. Think of Langchain as a translator that helps your AI not just to generate text but also interact with services like pulling data from APIs or completing tasks. Langchain helps it understand the criteria, fetch relevant listings, and organize the results. Like a smart assistant that knows how to get and use the right information. By now, you should have 3 API keys in your .env files: the SerpAPI, OpenAI, and Langsmith. Double-check that all these keys are correctly stored in your file. Now let's dive into how this whole process works, step by step, so you can easily follow along. The journey begins with the user. You initiate a request through a Python script that contains a pre-coded prompt. This prompt specifies the job listings you're interested in, including criteria like job type, location, and more. Langchain steps in once your request is made. It sends this pre-coded prompt to SerpAPI, a robust tool that fetches job listings from the web based on your specified criteria. After querying the web, SerpAPI returns a list of job postings that match your search criteria back to Langchain. Langchain then forwards these job listings to the LLM, which for this we are using OpenAI language model. The LLM processes the job data according to the instructions in your prompt, ensuring that the output is accurate and well structured. To ensure precision, the LLM employs a method called chain of thought reasoning. This technique, which I adapted from the React Chain of Thought template by H.W. Chase, helps the AI follow each step accurately and produce the desired results. Finally, the LLM formats and organizes these job listings into a clean, easy-to-read table. This provides you with all the job details you need in one place. Now that we've covered the overall workflow of the job agent system, let's dive into one of the critical components: how we fetch job listings from the web. This is where SerpAPI comes into play. SerpAPI is a tool that allows us to gather job listings from Google and other relevant sources. By integrating it into our Python script, we can automate the process of gathering job data, which is then processed and refined by our AI system. It fetches relevant job details from Google based on the job title you specify, such as Senior Software Engineer. Take a look at the script. We start by importing os.env Google search from SerpAPI and JSON. The .env module helps in loading environment variables, specifically the SerpAPI key. The Google Search Results module, which was installed via pipenv, provides the SerpAPI interface for interacting with Google Job Search through SerpAPI. The load_.env function loads environment variables from a .env file into your Python environment, including the SerpAPI key. The script job profile function is defined to take a job title called name as an argument, such as Senior Software Engineer. It then builds a set of parameters for the job search, including the SerpAPI key for authentication. The Google search function is called with these parameters to retrieve job listings from Google. Results are filtered to exclude unnecessary information like share_link, thumbnail, job ID, detected extensions, and description. Why filter data? Filtering the data before passing it to the LLM is essential to minimize the amount of token usage. This step ensures that only relevant information is processed, which optimizes performance and reduces costs when interacting with the LLM. At the end of the script, there's a commented out function called scrape job profile as a function of name, which for this case is a senior software engineer. This is useful for debugging purposes. By uncommenting it, you can run the script in debug mode to inspect the JSON content of the returned job results, ensuring everything works as expected. Let's get started with debugging by examining the breakpoints I've set up. I've placed a total of 5 breakpoints throughout the serp_job.py script. Each breakpoint is strategically positioned to help us inspect the key stages of the script's execution. To run the script in debug mode, start by clicking on the debug icon on the left side of VS Code. It looks like a small play button with a bug icon. Once you're there, click on Run and Debug. At the top, you'll see a drop-down menu. Click on it and select Python Debugger. Then click and choose Debug the current active Python file. After setting this up, click Run and Debug. To start the debugging session, you'll hit the first breakpoint where the scrape job profile function is called. This is where we'll begin examining how the code works step by step. Continue to the next breakpoint where the Google search object is initialized. Look at the params variable in the debug console. Ensure that all parameters such as the job title, location, and API key are correctly populated. This step verifies that the search setup is accurate before making a result to SerpAPI. Proceed to breakpoint number 3 after the search execution. Inspect the job result lookup variable in the debug console. Review the full set of job data returned by SerpAPI. At this stage, you'll see the raw, unfiltered listings which might contain extra fields that aren't necessary for your AI process. Continue to breakpoint number 4. This is the loop where the filtering occurs. In this loop, we removed unwanted fields like share_link, thumbnail, job_ID, and anything we want to exclude to minimize the token that will be used in the LLM. Then go to breakpoint number 5, where the filtered data is converted to JSON format. If you examine the filtered underscore data in the debug console, you will verify that all unwanted keys are filtered out. Review the returned JSON string in the debug console. Check that it contains only the relevant fields that you plan to pass on to OpenAI, confirming that the previous filtering and formatting steps were successful. Before we jump into the job agent script, let's go over some foundational components that are key to how our system operates, especially those from Langchain. Chat OpenAI is a Langchain module that allows us to interact directly with OpenAI's GPT models. It handles the communication with the language model, setting parameters like temperature to control how creative the AI should be. In our script, it's set to 0 for more deterministic, reliable answers, which is perfect when you need structured outputs like job listings. Second is the prompt template. This component helps define how we communicate with AI by structuring the prompts. We set up the prompt template to instruct the AI on exactly what we are looking for, such as filtering jobs that are full-time, remote, and based in Canada. This level of customization makes sure that AI provides results that match our exact needs. The tool component in Langchain allows us to define custom functions that the AI can call. For example, script job profile is wrapped as a tool, making it accessible to our job agent. This integration enables the AI to execute tasks beyond such generating text, such as pulling data directly from Google job listings using SerpAPI. The create React agent function is used to create a React agent, a type of agent capable of reasoning and making decisions based on the data it encounters. By combining our language model, which is the chat OpenAI, and the defined tools under the tool module, it forms a cohesive unit that can autonomously process information and perform actions like fetching and sorting job listings. The agent executor manages how our agent operates, coordinating interactions between the AI, tools, and input data. It ensures that each step, whether it's retrieving job listings, filtering them, or formatting the output, happens correctly and in sequence, providing a robust way to manage the AI's workflow. The hub module of Langchain is used to pull a predefined React prompt, which is then stored to React_prompt variable. It was designed to guide the AI through a series of thought processes, much like how a human would logically approach a problem step by step. This method is known as chain of thought reasoning. It allows the AI to break down tasks into smaller, improving the accuracy and reliability of its responses. It's like downloading a ready-to-use instruction set that tells the AI exactly how to perform reasoning and decision-making processes. Now, let's discuss our job agent script. First, let's take a look at the imports at the top of our script. We've imported some core Python libraries like OS and sys to handle environment variables and adjust our import paths. We also bring in key tools from Langchain, which help us build our AI agent. Finally, we load our environment variables like API keys using load_.env. This setup is crucial to make sure our script has all the necessary configurations to run smoothly. Next, we initialize our AI model with OpenAI's GPT-4. Let's break down the key settings here. Temperature is set to 0, which means the output will be more predictable and consistent. We're specifying the GPT-4 model. Next, we define the instructions for our language model using a prompt template. Here's the prompt setup. This prompt gives the AI a persona, acting as a job recruiter, and sets clear criteria like job type, location, and time posted. The format section is particularly important because it tells the AI exactly how to structure the output, making it easy to read and use. We define the tools that our agent will use, specifically the scrape job profile function that we talked about earlier. This tool is critical as it fetches the raw job data that the AI will process. Why is this important? This integration allows our AI agent to pull real job listings, refine them based on our criteria, and display them in a neat, organized way. Here, we are creating the agent that will run our job search process. We're pulling a pre-built prompt from the hub, setting up our agent with the language model and tools, and wrapping it all up with an executor to run the agent. The final part of our code is where the magic happens. We call the lookup function, which uses everything we set up. The agent uses the formatted output, runs the job search, and returns the job listings in a clean, organized format. We then print out these results so you can see them directly. Finally, when you run this script, it will search for jobs matching your criteria, and output them in a structured format. Let's see this in action by calling the lookup function. Running this code fetches the job listings according to the criteria we set and prints them in a neat table format, making the entire process of job searching a lot more efficient. Here's a quick tip. This script isn't just for job searching. You can easily adapt it to use other uses like fetching the latest stock trends, news, or any real-time data using APIs like Google Finance or SerpAPI. Imagine setting up a similar agent to track stock prices, monitor news trends, or scrape data from different sources. This code is versatile and can be your go-to for various data retrieval tasks. If you're interested in seeing a tutorial on adapting this for finance or other applications, like this video, subscribe, and drop a comment with your ideas. Your feedback helps us create content that fits your needs. To learn more about AI topics such as prompt engineering and image generation, check out these videos.